shelly filled up for us. It's not deep enough. But more seriously, don't leave your weights up on the edge of this combing because it's going to land on somebody's feet. So I'm not going to do anything. Everybody take your hands out of your pockets, put your water bottles aside because you all have to do this. And I'll do everything just by explaining, but you all do it. First thing you do is you ballast the vessel so that the draft fore and aft is different, so we have some trim. So you all choose how to do it. Here are some plates, and when you wedge the ballast, make sure that they can't slide athwart ships, port and starboard, left and right. So choose a plate that can get wedged gently inside the vessel.
A lot of water?
Yeah, the wiper will take care of that periodically. Just before data collection,
It's a wire.
now you have to choose plates that won't slide around, so I recommend these plates. And record what letter, Shane, you put in what compartment.
You want me to put it in the hole or on the deck?
In the hold is good, but it might not fit in that one. There are smaller ones that could fit there. That one is a special weight that we use for our incline. That's the way we're going to move around, so you don't need that one.
This is F.
Then there are others down here as well.
He wants to create a trim.
Now I recommend not using plates that'll slide around because we're going to, in another lab experiment, we're going to put this ship over about 80 degrees. And so just plan on all these weights that you put in aren't going to go anywhere.
So they're going to be the same weights throughout all these experiments?
Yes.
Do we want a little bit of trim in the ship so that we
Yes.
can calculate where LCF is?
Well, also.
Yes. But more specifically, where else the key is.
Weights are made at certain locations.
And we'll get to it later. So when you put those weights in there, Morgan, I recommend putting them so you know they're going to slide. So put it in here, let's say. And then if you cock it a little bit, it'll be pretty secure.
It's.
As long as you know where you put it. Because a week from now, you won't remember.
That was my gauge.
So if you haven't done anything yet, pull out a piece of paper and sketch a profile plan and maybe a full breadth plan showing where each weight, each carb compartment is.
Can we use the last blank sheet in the lab right now?
Sure. And then this is our incline weight, which will move around with our ruler. I'm not supposed to do it. And I think it's best to put that about in this compartment here with all these pencil marks. Do we have any weight up forward?
No.
Okay, this would work. You don't have to have weight up forward.
So, yeah, it's out of the water. It's,
Get out of the water, so we do need some ballast forward.
Just like some water filling.
Now, if we do allow some water to flow in there, which is a good comment, it's a valid comment, I want to come back to the statical stability curve that we will create someday. And yesterday when I drew the statical stability curve, I said that it makes an assumption.
lined it up right.
We don't have any baffles that were center line.
Oh.
Didn't fit.
True. And I also said there's no flooding. It assumes no flooding for the
It's kind of
statical
going this
stability
way.
curve.
Is it?
I don't know if that's what that one's at.
I don't think it's gonna put our bow.
Yeah.
Just
Well,
get
why
those.
won't the letter I work?
It won't fit. Won't fit. And if we put it here, we don't think it'll put the bow back in the
Why
water.
don't you try that again?
In here?
Yeah, but put it in the other side first. Okay, that'll work. And then cock it.
What do you mean cock it?
There you go. If you leave it like that, it can still slide later, a little bit.
Trim it
So if you
or
twist it, no, it's not
downdraft
just
it
twist
too.
it.
Oh, okay.
Does that work?
Or,
I mean, you're right.
Reopen here.
okay.
So I said, let's
Yeah,
get
that'll work.
suggest you do is roll this micrometer. I'll do it the first time. So it reads 0. That's the level, and a long way to go. I should have asked Shelley to crank this around as a student worker, have this all ready. I don't know, who in the world did that? See, what can I talk about for, yes, please, because I did say I didn't want to do anything.
Letter is that weight?
Good question, I have absolutely no idea.
The one that's at,
This
that's
one?
A.
It's A?
It's upside down.
And then you have another one in there?
And this one's F and this one.
What you guys got up there?
Good question.
D in the third station back?
Third compartment. This one.
So I recommend you draw a profile plan and a full breadth plan.
Yes.
Which one's that?
I.
And then the other thing you have, I don't know if you all recorded this, but you have your incline weight as well somewhere
Oh,
in one of these compartments.
shall I label that one I?
No, because it's already 9. This one's I. Fourth compartment.
Oh, there's that.
A lot of people ask, should we go off and weigh these ballast plates that we put on board? And the answer is no. The only thing we have to weigh in that equation,
This is the ship.
and we don't weigh the ship either,
We use the draft.
we weigh the incline weight. That's the only thing we have to weigh.
Oh, yeah.
Wonder who took the time to get that thing so far out of whack. Now, when you get close, make this so it reads 0. Here's degrees and here's minutes. So degrees and minutes. 0, 0. Okay, and now why don't you move that, I think by default, you're gonna become the operator of the inclinometer.
Okay.
Move this weight gently to try and get the bubble in the middle. And from here on out, as we start to collect data, it'd be best if you all maybe help stabilize the boat, but work with Shane so that it doesn't bounce around. But just tell Shane you're, doing something so he's not,
105 Ks?
because he's trying to center that weight.
I think it's 0.15 kilograms.
But don't record that weight. I wrote down some weird numbers there so that you all record it, but we're gonna have to weigh it. We'll get to that in a moment. Okay, while he's trying to center that, you guys can record the drafts fore and aft. I recommend you read the draft port and starboard, take an average. Read the draft fore and aft and take an average. I'm sorry, port and starboard forward, port and starboard aft. Take the averages of those two ends. And those drafts are in centimeters.
7. I'll get that.
I think that's pretty. True.
So you guys will take the average of yours and record it for draft aft. You'll take the average of yours up forward and write that down. And then you have it on your data sheet, you have a spot to write this down.
Oh, that's the camera.
David, will you hand to me my pieces of paper
I'll get it later.
so I can orient your data sheet?
Second? Yeah, that's the forward.
Thank you.
0.07.
So for you
I
all,
got it centered.
good. And
What was the back?
either mark it
35 centimeters.
or remember
It's
what
what?
mark you were using. Mark it somewhere. And we're gonna move this port and
What'd y'all
starboard.
get for the front?
7.
Average.
7.
So you're gonna record your draft aft or forward in this column here. It'll be the same throughout the experiment.
8.35?
Yeah, that's what we did.
All right. Got marked.
What was the graph?
I'm gonna go 8.25.
8.35.
One of the things that we can get off of this is the height of the incline's weight center of gravity above the keel. How can we know the height of that block? The height of the centroid of that block, which is perfectly homogeneous above the keel. We might need a better ruler for this, because that one is long.
One doesn't have a flat end on it.
I think Spencer has a ruler with a flat end on it, a drafting tool.
I have a, yeah, I've got, scale.
But you want to, how can you know, Shelley, how can you know the height of the center of gravity of that block right there?
I'm machine tool.
Yeah.
That works better.
Take a look at it. How can you know the height of the center of gravity of that block above the keel?
This is F, and that's A.
Look at, where it's positioned from Q.
Like measure the height of it, and then divide by 2. Good. So he's going to measure the height of that block and divide by 2, and that is the third to last column, the inclined weight center of gravity, which is one of the numbers we need on our
2
equation.
and 5/8 tall, so half is 2 and 5/8.
Now is that inches or centimeters?
Inches.
Now this whole thing is in metric. You might recall yesterday we did the whole, we built the hull in SPE, and it's all in meters and centimeters and kilograms and all. So we're going to use metric for this problem.
65 millimeters,
So up at 232 and a half.
32 and a half millimeters.
So 3.25
5.
centimeters. Okay, so you can write that down as the height of the center of gravity of the block. We can go weigh the block at the end after. Shane spent a lot of time trying to position that block, so let's not take it out and go weigh it yet. But we'll go weigh it over there a little later.
Is it 2.54 or 2.45?
I have absolutely no idea.
What's that?
Shane might know.
3.25. Why?
I was trying to convert inches to centimeters.
Well, it's 65 millimeters, like exactly.
All right, so now for trial number 1, I recommend we move the block to port for starters.
That's the weight.
All right, so, and the ASTM says that when you run this experiment, you must have a very small angle of list that you induce. You might recall in class I gave a number not to exceed of what, to assume that M is constant. 10 degrees. The Coast Guard told ASTM to come up with a tighter number. They limited it to 4 degrees. So when this experiment's really done, it's 4 degrees. It's going to be hard to see 4 degrees, but that's what we're going to do. So we have an inclinometer. It wouldn't hurt to put your phone in there and see, but let's not, because it affects the center of gravity of that thing. So you know where you start, right? And you're going to move it a certain distance, measure that distance to port, and then you're going to read the angle that was necessary to reach 0 of the bubble.
Okay, how far do I want to move it?
In the past, you've gone maybe all the way out to here ultimately. So maybe go 1, 2, 3/3 of the distance you might go.
3/3?
Well, this is, you're going to be able to go all the way out to here.
Right, so we want to do 3 different stations.
Right.
Let's see.
Okay.
And you want to get some number. So you moved it, you can measure the distance, and you can 0 the bubble. And count the number of times you go around 0 here.
Okay.
Somebody stabilize the bow.
Well, I gotta go this direction.
Best way, before you move, anybody are good at driving a trailer? You know, like a horse trailer or anything like that? What's the best way to back up with the trailer? Fast or slow?
Straight.
Fast. The faster you go, well, not totally, but if you try and go really slow with that horse trailer, you're going all over the place. Once you get up to some reasonable speed, you can drive it better. So similarly here, you need to kind of get moving to know which way the doodah goes, the vernier scale. And hopefully you're counting the number of times you're passing 0. And you decide if you're pushing that bubble tighter in there or looser in there.
Yes, sir.
So get back to what you thought was 0 and count from there. Is my analogy any good about backing up a trailer?
Yeah, everybody can say back of the trailer works.
Is that it?
I'm done.
There you go, now you're getting close. Like, went too far.
She jackknifed my neighbor's trailer, screwed up a bunch of panels on it,
And just recognize, Shane, while you're doing that, and they're bailing up forward, it does get a little more difficult. He does have to get the water out, so you might wait for him to do that.
Why don't we, get a new seal for that plug?
Flex seal.
We need a,
Yeah, just flex seal it.
Okay.
That's
we need
good.
a, student worker to, now unfortunately, the steel plug itself has a little cut in the face of it, unfortunately, so it has to be reground. Okay, ready to go?
Grind it.
Student worker? You take care of that? Great. And you counted the number of times you went through zero, so that's degrees and then minutes.
Okay, all right. I think I went like one.
You think you went like one or went one? It's important to know if it's 1 degree or 2 degrees.
I remember this left. So yeah, finishes to 0.
It is very important that you know how many times you went through zero.
Yeah, I only went one, but then I had to go back.
So do you
So I
want
think
to,
I'm less than
you want to start over?
Yeah, probably.
So put the weight back there and re-zero it. And make sure you count the number of times you pass through zero. Now don't blame Shane, because it does get tedious to operate that little vernier that's very difficult to read. So everybody's patience is best shared.
Okay.
Negative.
34 minutes.
And then distance. So everybody write down 34 minutes. And what I would say is your initial list is 0 for that left column. The initial list is 0 for the whole thing. You can just write 0, 0, 0, 0, 0. Shane did a good job of zeroing the heel,
And
the
because,
list.
15
because
millimeters.
this is port, is it negative?
We'll just call this port or starboard, not
Okay.
neither negative nor positive. And the reason, well, I'll explain that a little bit later. So everybody wrote down what he said? The
15
distance?
millimeters.
15 millimeters. Or, what's that, 1.5 centimeters?
115, right?
And you're gonna write that down as port, list is
Yeah,
to port. And the angle, the final list was what? 34 minutes. Who knows how to write minutes?
0 degrees, comma, 34 apostrophe.
Apostrophe. Now, what's tricky about this, if you happen to go use Excel and you write in the number 34, it's not going to know what it is. If you write in 34 degrees, it's going to think it's actually 34. If you take the tangent of that, it's going to think it's radians. So pay attention. Oh, and also another thing you might do wrong is convert 34 minutes to degrees. Like,
Divide by 60.
correct. A lot of people say 1.34, and it's not 1.34, it's 1 and 34 over 60. So bear that in mind when you get to use your calculator or Excel.
So,
So for
Okay.
Excel, you have to convert to radian.
Excel defaults, I don't know how it was last left, but Excel defaults to assuming the number you type in is radians. If you hit tangent of a number, it's going to think the number is in radians
So that's 34/60th.
of a degree. Yeah. So if you, yeah, and then go farther
What
to
was the
port,
list?
Okay.
and you notice you went 1 point whatever centimeters, so you could double it or triple it. You have a long way to go still.
Yeah.
And that was only a half a degree, and you come out to 4 degrees, so. And then do that again. Make sure you count the number of times you pass through 0.
Yes.
body.
Correct. So that's 1.
Yes.
So did I.
You talk with him, let him know you're bailing a bit.
I'm just getting a little water out of here.
Now, it's important for you to assume something on this experiment, and that is no flooding, no free surface effect.
Is that all good?
Is that true? I
Yeah.
don't know.
I mean, I'm gonna keep moving.
Source of
Every
error.
time somebody puts
What?
their hand on the source of error, this thing.
It is a source of error.
Kilometer.
Okay, we're good.
Alright,
Trying not to touch it.
1 degree, 28 minutes.
So that, remember, that'd be 1 and 28 over 60 degrees. And if you go convert that to a decimal,
Hold on, man.
Excel's gonna think that it was in radians, and you have to convert degrees to radians to degrees, or degrees to radians.
Well, it might be moving because of the dang flooding, so you might want to just take the previous reading.
Yeah. 1 degree, 20 minutes.
And then the distance that you moved from your original position.
Further out.
51, 5.1 centimeters.
From the center line.
52, 5.2. Yeah,
And you took off that 10, right?
yes. It was at 62.
Good. And let's do another one, farther to port.
We assuming that the initial is following 0?
Yes. No, the initial list is 0 for all of them. And notice we're just going a little farther out to port, and we're getting a little bit more of a degree of lift. And the distance is always distance from 0. That's what Shane is reading to you. And the degree change is always from 0 as well.
And the last one?
Yep, and good time to bail maybe.
I'm just trying to act like a loose rope over here, just kissing it.
You're great.
When,
You make a hell of a rope.
when a real incline is done on a ship, they'll have inclinometers, 3 of them stationed, 1, 2, 3. And typically, the inclinometers, you can keep going, is a long pendulum, about 30 or 40 feet, hanging down in a escape trunk, if you're familiar with what an escape trunk looks like. It's a long shaft, vertical, and that pendulum on a piano wire is just hanging there. The ASTM will explain a lot of this.
Well, piano wire.
Well, a piece of wire, not piano wire necessarily, but it looks like piano wire.
You could use a electronic tuner and strum the piano wire and figure out how heavy the weight is.
Or you could just measure.
The more you know.
Are you musically inclined?
No.
Oh.
2 degrees, 32 minutes.
And that uses up all the numbers.
Say 3 degrees.
You said 2 or 3?
2.
So what was it?
2 degrees, 33 minutes, 32 minutes.
So in reality, all of you should have 4 data points so far. I see 4 on Alex's and I see 3 on Shelley's. Alex, will you say what your first one was?
0's all the way.
0 all the way across was your first data point. So you actually have 4. Now we're gonna go back to 0 and do the same thing to port, and at the end, we're gonna do 0 again, and it might not all be 0. So let's go back to, we already know where 0 is, so now you can go shifting to port.
We're gonna
It
measure
is-
this quick.
I mean,
We haven't
starboard.
done it
Yeah.
And Shane, I have to explain something about this micrometer too,
Yes, sir.
when you're ready to listen.
93 millimeters, 9.3 centimeters. Yes, sir.
Can I see your data sheet, because you
I gotta
have
move everything down.
4, but you,
I'm moving everyone down, so I didn't take the initial, all the 0.
okay. Shane's going to get a cup of coffee, I think. He'll be back in an hour.
Make it 2.
Everybody take a break.
So why doesn't the far forward compartment or the far aft compartment have a drain plug to flood it? These ones pollution.
Good question.
Russian collusion.
There's no reason, like mandated by Congress as to whether there is or isn't one, or the Coast Guard, or ASTM, or the manufacturer. I think they just chose to.
What about like a Ford collision or something?
Well, good question. This would be considered a collision bulkhead here, and this would be considered the aft piece bulkhead. But flooding could still occur in those things, so, but this model is just not set up to flood them. So.
Mine's not even deep enough to be below a water line.
Yeah,
On
good,
this side.
good observation. It might be if we ballasted more, or if we started having flooding here and then it might go underwater.
So what's the secret to the income?
Okay, so put it back at 0. Satisfy yourself, you went through the requisite number of zeros.
For $40,000, we should have plugs back here.
We should have a plug that works.
No, that's the $50,000 one.
And just eyeball that you're about right. You don't have to be exact, but you agree that you're about right there. Okay, good. So notice when you turned it this way, when the weight went to port, what would be that reading if that's how far you moved it?
It doesn't matter, I've been standing in front of it like half.
Now notice this. What if we move it to starboard and you move it this far? What would be the reading?
5 minutes.
And we're probably gonna have
So
to,
that's
so
what you
it'll
have
come
to
to us,
figure
we're
out.
like,
60 minus what you read when we're going to starboard.
Yes, sir.
It reads backwards.
We'll move it,
They just got within
1.5.
cell range this morning in Florida.
oh wow. We'll text people and just be like,
What about
so, how's it going?
The ship got within cell phone range this morning.
Oh, really?
They're supposed to pull in today.
I
Okay.
think so. They usually don't come close enough
Kennedy.
unless they're pulling in port.
Yeah.
June taxes, be like,
My understanding is they pull in today. Anybody know what yesterday was in history?
it was D-Day.
D-Day, 1944. And also 100 years ago yesterday was the Battle of Belleau Wood, which was a major World War I battle. Huge battle in France. Belleau, B-E-L-L-E-A-U.
60 minus 30. 26? Yeah. 26 minutes.
26.
And this is now to starboard.
26 minutes, what?
So,
Starboard.
you take an initial list coming
0
back,
Zero
as
degrees.
6 minutes.
we went
We're
out.
going the other way
No,
now.
Okay,
we will do
so
it
what
at the end. That'll be our 8th
We
data
just
point.
went to the center line, now we're going starboard.
Stab it.
You think that'd be because some of our ballast weights are off center?
What distance?
Could be, yeah.
Did you get the distance?
Yeah, 1.5 centimeters.
No,
I'm trying to.
I think it was, oh, you're right, okay.
1.5.
I have that 26 in my head.
I'm trying to use whatever we did before.
Last time, did you go all the way out to the bulkhead?
Yes, sir.
Am I stealing a good spot here? Do you guys want to get in a little closer so you can see what's going on? I don't need to stand here.
Okay. 2 centimeters.
6.2.
Was it not 5.2 for the port side?
It is 5.2.
You subtracted 10 centimeters, so 10 millimeters.
Oh, yeah.
From your thing, so.
I think I'm gonna pick this camera up and get a closer shot of what they're doing in
Okay.
there.
I did it wrong.
So Shane, you corrected that -10 business, or you're about to?
Yes, I did.
Okay, and that's been corrected?
Yes.
And thanks for whoever spotted that.
Yeah.
Yeah.
Action cam. Action cam. Action, action.
a bit of flooding up here.
Would you take care of that while working with them?
Shane, I'm gonna get some water out of here.
Don't dare. No, go ahead.
Alright, Shane, can you explain real quick what's going on here? You're just moving that until we reach a zero on that.
We're just turning this, adjusting the micrometer until this is level.
And, back here, sorry.
To give us the incline based on the degrees and the minutes.
Gotcha.
Shane, emphasize a couple of things. One is the need to count the number of times you pass through.
Yes, count the number of rotations.
Also, emphasize the point about reading the vernier backwards.
Yes. So whenever we're going port, you read the vernier forward, just 1 through 60. But when you're going backwards, you have to subtract whatever your number is from 60 to figure out your minutes.
Maybe a demo would be good at the end of this for that, because that can be confusing when you've got
Alright,